When a mass is rotating in a plane about a fixed point, its angular momentum is directed towards a fixed point. A mass is rotating about this fixed point O. This length is r, speed is v. Angular momentum will be r cross p or r cross mv or m r cross v. This is r vector, position vector, and this is v vector. L की जो डायरेक्शन होगी that will be perpendicular to the plane comprising R and V. Hence, direction of L will be a line perpendicular to the plane of rotation. A is correct option. Next, two persons' masses 50 kg and 65 kg respectively are at opposite ends of the boat. The length of boat is 3 meter and weighs 100 kg. 55 kg mass walks up to the 65 kg man and sits with him. If the boat is in still water, the center of mass of system shifts with. बोट है, यहाँ पर एक 65 kg का मैन है, पर्सन है, और एक 55 kg का पर्सन है. और इसका वेट 100 kg. Finally, this 50 kg वेट का पर्सन वो 65 kg वेट के पर्सन के पास आ जाता है, सिट्स, इसके पास में बैठ जाता है. जो सिस्टम है, सिस्टम ऑफ both person and boat. No external force has been applied. Hence, no horizontal external force, hence there will be no displacement horizontally in the center of mass of the system. Hence, C is correct option. ABC is an equilateral triangle with O as its center. F1 and F2 and F3 represent three forces acting along the sides AB and AC and BC, AC respectively. Total torque about O is 0, then the magnitude of F3 is. ABC ट्रायंगल है, O से डिस्टेंस परपेंडिकुलर डिस्टेंस सपोज R, तो ये सभी जो लाइंस हैं उनसे डिस्टेंस विल बी सेम एंड दिस विल बी R. Torque about O. F1 का टॉर्क होगा F1 इंटू R, अगर हम एंटी क्लॉकवाइज को हम पॉजिटिव लें एंड क्लॉकवाइज को हम नेगेटिव लें तो F1 इंटू आर प्लस F2 इंटू आर माइनस F3 into R, and this is given 0. F1 plus F2 minus F3 is 0, hence F3 will be equal to F1 plus F2. A is correct option. Next, a circular platform is mounted on a frictionless vertical axle. Its radius r and its moment of inertia about the axis is 200 kg meter square. It initially at rest. A 50 kg man stands on the edge of the platform and begins to walk along the edge at speed 1 meter per second relative to ground. Time taken by the man to complete one revolution is. एक सर्कुलर प्लेटफॉर्म ये एक्सिस पर माउंटेड है, ए ओ बी एक्सिस पर, ओ ए, इनिशियली इट इज एट रेस्ट. इसका इनर्शिया इज 200 kg meter square, radius is 2 meter. A man is standing here. The mass m is 50 kg. Initial angular momentum is 0 because the speed of system is, every part is in rest. Man moves with velocity, with speed v 1 meter per second. Suppose this point जो initial था A पर, and this platform moves in opposite direction with omega radian per second angular speed. The final momentum will be momentum of the person with respect to O, mvr, and momentum of this system I, momentum of this platform I omega. No external torque is applied on the system, hence this LF will be equal to Li, or mvr minus I omega will be equal to 0. 50 into 1 into 2 minus 200 omega is 0, and omega will be 100 by 200, 0.5 radian per second. Angular speed of person omega m will be v by r 1 by 2, 0.5 radian per second. So, man will move anti-clockwise and this platform will move clockwise. Relative angular velocity of man with respect to platform omega and omega are in opposite direction, hence they will add up. Total angle revolved by platform is 2 pi radian. Hence, time required angle upon relative speed 2 pi by 1 is 2 pi second. This C is correct option. Next, the moment of inertia of a uniform circular disc is maximum about an axis perpendicular to the disc and passing through. Suppose the mass is m and radius is r. The moment of inertia about A in perpendicular to disc is Ia, and that is mr square by 2. अगर कोई एक पॉइंट हो F पॉइंट और इससे स्मॉल d डिस्टेंस पर है A से, तो मोमेंट ऑफ इनर्शिया अबाउट F will be I and perpendicular to the disc, IF will be IA plus md square. So, moment of inertia depends on d square. तो जिसका d is maximum, उस पॉइंट पर मोमेंट ऑफ इनर्शिया is maximum. Hence, the moment of inertia will be maximum at point B, and A is correct option. Next, three masses are placed on x-axis, 300 gram at origin, 500 at x 40 centimeter and 400 gram at x is equal to 70 centimeter. The distance of center of mass from the origin is. This is origin per x is 0 and mass m1 is 300 gram. Next, इसको हम x1 मान लें. x2 is 40 centimeter and mass is m2 500 gram. Next, x3 is 70 centimeter and mass is m3 400 gram. Distance of center of mass x from the origin is m1 x1 plus m2 x2 plus m3 x3 upon m1 plus m2 plus m3. 300 into 0 plus 500 into 40 plus 400 into 70 by 300 plus 500 plus 400. 0 plus 2 into 20 into 10 to the power 3 plus 28 into 10 to the power 3 by 1200. 48 into 10 to the power 3 by 1200 is equal to 40 centimeter. A is correct option.